Okay. Oops. Let's see if I'm connected here. I don't want to be on that microphone. Working? Are you guys on the other end able to hear me? Put a check mark on the other end if you can hear me. So Amanda and Krista, if you can hear me, can you put a check mark, please, so we can let know that you can hear. Okay, let me try going back to the other one. I understand it's in the computer today. They can hear me on that end. And so today, like I said earlier, we're going to talk about Pythagorean theorem. Last week we learned that it's the two parts that make up the right angle. If you square each of those sides, that equals the same thing as the long side that connects those two squared. And we're going to actually take that and use that today as we move forward, and then talk about higher roots, which means instead of just square roots, just like you have two, like you can square a number or cube a number, you can square root a number, or you can cube root a number, or you can fourth root a number. We're going to talk about that today. Okay? So, I didn't write this on here. I thought I had, but I didn't. So let me type it in here so you guys can get the essential question for today. And make this just a little bigger. Okay, so we're just going to do how do we use the Pythagorean theorem to solve a problem. Do you want the actual Cornell note template, or just want a piece of paper? I've got it right now with the brown paper one. All right. Ready? Okay, if you're ready on the other end, give me a quick check mark, please. I'm hoping. If not, we're going to have to go back and put it up at the end. All right. So just remind me if I need to. Here's some vocabulary we're going to talk about today. So let's get those things down and make sure you add in some of the definitions or information about these things as we go along. So leave some space to write. Yeah. Okay, a couple more seconds here, and on the other end, on the away from the site ends, if you just give me a check mark when you're done copying those down, that way we know you're ready too. And I know that you guys are going to help me keep an eye right up here for right in this area, in case this starts some question areas, little bubble things inside there. Bubble. Okay, remaining. Okay, so this end is ready to go. Looks like everybody here is pretty much ready to go. So remember last week we talked about the different squares. We did a little experiment where we put the squares out and we tried to put them together, and then in the second found out which ones would be right angle and which ones didn't. And one of the things that you came up with, we found out, was when we have something such as, let's say the side length was 3, 4, and the long side was 5, that the area was 9 and 16 and then 25 because they're squares, right? So we had to 5 squared or 5 times 5 to get the area. And then we found out that the small area, so we got 9 plus the 16 for the medium area, that made 25. And we found out that was happened to be the same as the large area, and that did make a right triangle. Okay, and so like was mentioned earlier, we found out that if the small area, or the side squared plus the other side squared, made the long side squared, that you did get a right triangle. So, and some of you I know tried something like this, maybe 6, 8, and I think one of them was 12, and you found out if I squared that I get 36, 64, and 144. That if I said 12, or excuse me, 36 plus 64, that gives me 100, and that does not match the large area, and so therefore it is not a right triangle. So we kind of found that out last week. There's a couple examples, right? So what we're going to focus on, though, is the right triangle part of it, because that's the Pythagorean theorem. So when we talk about the Pythagorean theorem, oops, went too fast. We said if 3 squares have sides that make a right triangle, okay, then the sum of the area of the 2 small squares is what? So don't do dot, dot, dot. What are you guys going to do? You're going to fill out this in there, right? Okay. Okay. So again, what did you guys put as the dot, dot, dot? So the three squares have sides that make a right triangle. And the sum of the area of the two side small squares is what? What's your Nathan? Sorry, Brandon. Are equal to what? The two small squares, the sum of the two small squares, the area of those, is what? Good. Equals the large square. This is the area of the large square. Good. Yeah. The sum of the area of the two small squares. And so on here you should have okay. And this is nice to write this way, but most of the time when we see it, what we see is, we see something like this. The side that makes the side that makes the right angle, or the two sides that make the right angle, are called legs. We call them legs. So one leg squared plus the other leg squared, because if I square them, I'm getting that area, aren't I? Because if the area squared is the number times itself, so it's squaring. If I have a square, and it has length 5, this side is also 5, right? Okay. So 5 times 5 is the same as 5 squared, right? So that gives me the area of that square, right? Okay. So if I say leg squared, like I did right here, okay, that's the same as what we just said here, the area of the small square. Saying leg squared is the same as saying the area of the square, because 5 times 5 gives me 25, which is the area of length times width, right? Okay. Okay, I'm glad you asked that question, because sometimes that's not as clear. Sometimes I make assumptions that people remember something like that, and so, or make that connection. So thank you for asking. Okay. So I've got the area of the small square, the area of the medium square. And I say, again, because the length of the side, we're talking about the length of the side there when we say that's the 5. Well, the number here is the length of the side. Square, it gives me the area. Okay. And we call, when I have the angle, like the triangle here, I didn't do very good right angle, so I'm going to tell you it's the right angle by doing that. This side is the leg, and this side is the leg, because they make up the right angle. Okay? That helps see it better. Okay. And then the long side that's opposite the right angle. Can you see how that's opposite? The right angle is kind of pointing to it. Going this way. This is called the hypotenuse. And I'm going to sometimes abbreviate HYP when we have enough space. Okay, so that equals the hypotenuse squared. And I'll spell it. You guys saw it spelled out on your paper there. So your vocabulary words. So if I know the length of the side here, and then the length of the side here, if I square this one, I square this one, and we get the length of this side squared. We're going to look at that in just a second, so you guys can really see what that means in terms of numbers. So I know using words or letters all the time now sometimes can get confusing, right? So we're going to look at that in terms of numbers so that it makes sense. Okay. So want to make sure everybody's got. Yeah, everybody's already done. So make sure you have it. Okay. All right. So, if I go on, yeah, you can go sit at the office and ask them the same. Okay. All right, so got our patterns, and so what we need to do now is we need to use that idea of leg squared plus leg squared. Okay, so leg squared plus leg squared equals the long side, which is called the hypotenuse. And so the question says, so use your patterns from the activity that we did last week, which we just wrote up at the top, to decide if the side lengths listed below will form a right triangle. So what I want you to do is take a couple minutes and look at these things. You know, notice these are already squared, right? How do you know these are already squared? So then just square. So these are the areas already. So are you going to square these? No. Okay. So what about these? Yeah, because those are the lengths of the side, right? So you want to carefully with the inside there. I'll put some of it to this way. And look at the side. Are these things in the area, or which of these things make the right triangle? Okay? And you guys can work together and talk about it together if you want to. Okay, well, remember the length of the shorter side, the two shorter sides, right? And then your two sides that make up the right hand. And the hypotenuse is the longest side. So we're going to use our leg square plus our leg square plus hypotenuse square. That's right. And those two legs are the first one. What's the first one right here? What's the leg? It's an 8. Good. Okay. There's several. So they get to practice this idea. Okay. How are we doing on these, guys? Okay. How are we doing on this? Well, last time we kind of already explained, but we'll do it one more time. Should we go over these and check these out? Yeah, you did? Yeah. Okay. So the first one here, they give you all the side lengths. Okay? So you're going to have to, this one you'd say 6 squared plus 8 squared equals 10 squared, and calculate it out to see if that's really a true statement. And in this case, was it a true statement? Yeah. So this is a square, or a right triangle. How about the next one? Okay, it's not. But what was unique about this one again? What did they give us? Mm-hmm. Right. So if you talk about the length of the side on this one would be 8. The length of the side on this one would be 10, and the length here would be 12, right? And they've already squared those for you. That's why it says inches squared. Okay. And when we're talking the leg squared plus leg squared equals hypotenuse squared, we're talking about the length of those things, and then when we square it, we get the area. So they were already squared because it says they're already squared with the inches squared. So all you have to do is say 64 plus 100 and see if that equals 144. And we found out that it does not, because you can see very easily that 64 plus 100 is 164 instead of 144. So that's not equal, so that is not a right triangle. How about the last one? That was a little trickier. You had to read very carefully, didn't you? And just about everybody caught on to that, and that's really good, because that's kind of like I was telling somebody that was like the unit part 2 test, where you have to read so carefully to make sure you get picked up all the details, right? That's one of the hard things about math, is that you have to pick up the details. Okay? And so most of you caught that, and you said the 2 legs were 5, because if you square 5, that's 25, and that's smaller than the 50 squared, right? And then you caught on that the 50 was the area, so you didn't have to square that. You could just put this down right here. And so 25 plus 25 does make 50. So is this a right triangle? Yes. Okay. And then it says explain again how you know whether 3 squares will join at their corners to form a right triangle, because we know that if the length of their side squared plus the length of their side squared, which we call leg and leg, right, equals the length squared of the area of the third figure, then we know it's a right triangle. Okay? So, how can we use that? We're going to use that to find a missing side. I'm going to call that each of these missing sides X. Okay? And again, I put up there the relationship discovered is called the Pythagorean theorem. It's 11. Yeah, I don't know why there's a little mark there on there. I have no idea what happened there, but it's there. It's 11. So we're going to use the idea of leg squared plus leg squared equals hypotenuse squared, and you can see the hypotenuse spelled out this time. And use that idea to figure out how long the length of one of those sides is. Okay. Yep. Yeah, and that's actually what leg squared plus leg squared equals hypotenuse squared is. That is, I like to use those words, at least when we're first starting out, because that helps me know what we're really looking at and use the actual vocabulary. Okay? So let's try A and let's try C. And if we need to try the other 2, then we can, but I'm going to try A and C. how can we use what we just learned with the film today here, before you remember that. Okay, you can weigh and weigh and accomplish what the A and B and C actually represent on the triangle. Okay. not sure what word that means, but I set it up as it was just 10. Okay, how we doing? Okay. So, as you do this, most everybody's got something down. Recognize the 3 and the 11 in A were the legs. So you said 3 squared plus 11 squared equals, and some of you forgot to put the squared on the x, so don't forget that, okay? Because it's leg squared plus leg squared equals hypotenuse squared. And then you worked it out, and you ended up with 130 equals x squared. And then to do that, you can square root both sides, okay? And then you're then you can get your answer. And square root of 130 you can't break down, so just x equals 1 square root of 130. And remember, if it's x squared, we don't know if it's positive or negative, so we could typically we put down positive or negative of that, but because we're talking about the length of the side, we can't use the negative one, right? So it's just square root of 130. And most of you did a good job with this. You did 6 squared plus 8 squared. So those are the 2 legs. Oops. Sorry, I got ahead of myself there. Equals x squared. And then that will help. You can work that out and get that. Now for C, it was a little trickier because this time the x was the leg, one of the legs. It's making it the right angle. So it'd be x squared plus 4 squared equals 5 squared. Okay? Now, D, and D would be a squared plus b squared equals x squared. And then to solve that, I can't add these together, right? It's just the way they are. So I'm just going to put a square root over it, and you can see that that's the answer right there. Okay? All right. So we've got a word problem here. It says the PE class is playing baseball. The distance between each base on the baseball diamond is 90 feet. Lisa at third base throws the ball to Dano at first base. How far did she throw the ball? So let's draw a picture of that. We've got a baseball field. I'm not doing a very good job here, but it's a diamond, and each corner is a right angle, right? And so Lisa's at third base over here, and she's throwing to the person at first base. So how far did she throw the ball? And the ball is going to go right here, right? How far is this? How long is this slide over here? What does it say? The distance between each base is 90. Okay, and it says that right there. You don't have to know that because if you're a baseball fan. And each angle here is going to be a 90-degree angle. So now that we have a picture, can you use what we've learned to figure out this distance? Can you see that we have a right triangle, and I can use that Pythagorean theorem to figure that out? Okay. So just quickly write the formula, or the equation. Don't worry about solving it, just to get the idea, because I know you can solve it. Yeah, it would be no, don't worry about it right now. I'm going to give you a page that has it on there. I have a page that has it on there for you, so you can refer to that page. You can see refer to the page. Okay, it has all the functions built in. So what you do want to make sure you play out is when you have word problems like this, what is important to do is to understand the problem. You have to do that. I read 3 legs, right? That's what we learned how to do, and picked out the important pieces. But before I could actually work it, I had to do what I hear. Draw the picture, right? And so when you're dealing with things, it's always important to draw a picture. Yeah, you can do it. So great, you're doing it. Okay? everything we know is if we expect our work problem and we can draw picture, right? And make a table or that kind of thing to help organize the information for you. So the next one that's on there, and I'll change this to the next slide. So Scott and Mark are rock climbing. Scott is at the top of a 75-foot cliff when he throws a 96-foot rope down to Mark, who is on the ground below. If the rope is stretched tightly from Mark's feet to Scott's feet, how far from the base of the cliff, directly below Scott, is Mark standing? And this actually tells me to draw a diagram and label it. So go ahead and draw a diagram of that. Draw a picture and label where Mark and Scott are. And label it with numbers and stuff. Scott's at the top of the cliff, Mark's at the bottom, they're stretching it up between the two of them, and Mark's standing right at the bottom of the cliff, and he's standing over away from it. Yeah, so what's that going to look like? And don't worry about drawing a stamp cliff or anything like that, just draw a line to show where the cliff is. Okay. Think about what shape are they getting here? Okay, most of these, it took you a couple of minutes, and some of these took a little longer than others, which is just fine. That's how your brain processes, and that's the way it works. And that's okay. Sometimes it takes some people longer, and this time it took you longer to process, but next time it'll take the other person longer to process. So most of you did a great job with this in terms of the picture. You figured out that there's the cliff, there's the distance, down here is Mark, right? Up here is Scott, and here's the rope between them. You said the rope is 96 feet, so you labeled that. You said it's 75 feet. Scott is 75 feet up. And then you said X, and most of you already automatically went to 75 squared plus X squared, or you could write X squared plus 75 squared, either way, equals 96 squared. And then you can figure out how far away from the cliff Mark was, right? Okay? And actually, the Pythagorean theorem they use a lot, like when it's shipping boxes and things like that, to see things fitting in boxes because of going at diagonal. Sometimes if you lay something flat in a box, it may not fit, but if you kind of diagonal it up, it will, because you have more length that way and that kind of stuff. So we use that kind of stuff for shipping and that kind of stuff out in the real world all the time. Or figure out if you can fit something through a door, right? If you got a big huge television or something like that, or like a couch or something. Sometimes if you tip it, you can fit it through. You kind of eyeball those things, but sometimes you have to actually measure to make sure it's going to fit through, the way you need it to fit through. So this is used all the time, and it's also used to make sure the corners on our houses are good right angles like they're supposed to be. People use this all the time. It's like they do all the time out in the real world. So that's an important thing. So I'm going to do a quick talking about this. Let's say this is 25 as an area. It's a square. So we know this is 5 times 5. So if I say the square root of 25, I know that that means it's 5, right? Because I ask myself what number times itself makes 25, right? What if I've got a cube? Volume is 125. Its side lengths are 5 times 5 times 5. So if I'm finding, this is also the same as 5 cubed, right? All right, so if I've got 5 cubed, then if I want to take, I can also take the cubed root of 125, and I just put a little 3 up front here. I could put a little 2 up front here, okay, for square root, but we don't. We just assume that's a 2, okay? So if I'm saying the cubed root of 125, what number am I going to get? What do you think? And the first one, I'm finding the length of the side of that square, right? What number times itself gives me the area of 25. For the volume, okay. Yeah. Yeah, so this is saying I need 3 numbers that multiply times itself to make this. This is that I need 2 numbers to multiply by itself. Okay? So I need 3 numbers to multiply by itself to make 125. So it's 5 times 5 is 25 times 5 is 125. Okay? So we're just taking that a step further for the last little bit, and we're going to actually kind of quit there. So basically, just one last little piece to help you get started on the lesson. You can pretty much work through this lesson yourself. So there's the nth root of a, and you ask yourself, what numbers raised to that power equal a? So if n was 7, you ask yourself, what number do I have to take 7 and then multiply by itself? Okay, what would give me the number that I then gave me. Okay. Or it just it has a formula that n is, and it's 4 of those numbers multiplied together to make it. So that's 16. If you do 4 through 16, it takes 4 twos to make 16. 2 times 2 is 4 times 2 is 8 times 2 is 16. So the 4 through 16 would be 2. It takes 4 twos to make 16. Does that make sense? Okay, there's also another way to write besides this that you'll go through the lesson. If you're going to see, and I want you to kind of make sure you go through the lesson. This one you can pretty much do by yourself. So I may add this to the extra credit part of it, okay? Make sure I get your name tags, guys. And